Hello everyone. So today we will discuss about the axial flow compressor. This is a very wonderful topic of the turbo machinery because here the flow starts in all the aircraft, jet engine, etc. This is the first and major component of the turbo machinery, mainly in jet engine and aircraft engines. So I have here made a schematic diagram of the axial flow compressor. Here we can see I have just shown the upper part of the axial flow compression. The lower part will be the same as the upper part will be the symmetrical. So I'll denote some of the things here, like this is the casing and this is the axis of rotation. Let me take this. Okay. This is the axis of rotation and this is the rotor and air is flowing from this direction. Okay. Now the very important part is that the green color here is showing the rotor and the green blades, these green blades are actually attached with the rotor. So these rotors are actually moving blades. So these green color blades are moving blades, and the white blades which are attached with the casing, these are actually the fixed blade. Fine. Now let's understand its. This is the side view of. Let erase it. This is the side view of axial flow compression. Now I will make the front view. Front view will be something like this. Like first I will make the casing. This is the casing part, and the and let us make this is the casing part. I can make it like this. I mean, if I'll draw the moving part, then the moving part will be attached on the rotor. So the moving blades will be. I should make the moving blades with green so that it will not be any confusion. These are the moving blades. And what about the fixed blade? Fixed blade will be fixed to the casing. These are fixed blades. Okay, so these are fixed blades and these are moving blades. This is the casing and this is the rotor. Okay, now let's see the arrangement of the blades. If we'll visualize isometric view of this blade arrangement, like if we want to see, if you will see this thing from, let's see, if you are seeing this thing from this direction, then you will get to know that it will be something like this. Let's make, I'll try to make this be something like this. So fixed blade, first of all I will make the fixed blade. So if I make a fixed blade, so fixed blade will be something like visible here. And the moving blade will be, this is the moving blade and it will be attached to rotor blade. It will be something visible like this. Okay, now if we want to understand its shape, so for that we need one more diagram. Like if this is the one stage, this this is one whole stage, and let's say this is the moving blade, this is the fixed blade. Okay, so I'll draw the moving blade, and then the fixed blade. I'm just showing the orientation. Don't get into the sizes. Sizes will be accordingly. Okay, so air will be going from here. This is section 1, 2, and 3. So let us try to understand its concept, how it is working like. So first of all, from this figure, one stage shown. Let's say air is entering from the moving blade, and then it is coming from the first stage from fixed blade. So we are seeing that the blade is something like in this shape, not this shape, not symmetrical like this. Okay, this shape. Why this shape? This shape is because we want some aerodynamic shape. This is aerodynamic shape. You can say that it will be in aerofoil shape. So what is the use of it? The use of is this. Because of the aerodynamic shape, we want to change in the pressure, and because of the change in the pressure, there will be change in the velocity, and because of the change in the velocity, we want the, I mean, whatever the pressure we want, we can manipulate according to that. I mean, for your understanding, let us say that this is first section, second section, third section. So what about the velocity? If I'll say about the velocity, here is 1, here velocity is 2, and here velocity is 3. So first, in the moving blade, the velocity will increase. Why the absolute velocity will increase in the moving blade, we'll understand later. Okay. And in the fixed blade, the velocity will decrease. In the fixed blade, why velocity is decreasing, you can directly understand here, because you can say that in this section, the section is somewhat diverging. Section is diverging, and because it is fixed blade and diverging, so whatever velocity is going, and if it is in subsonic state, so velocity will absolutely decrease. Velocity will decrease and pressure will increase. This is the funda. And I'll talk about the pressure, then pressure here P1, P2, P3. In the moving blade, I'll make understand the moving blade further in further slides. So pressure in the moving blade is increasing, and the fixed blade is increasing. So you can understand the why the pressure is increasing the fixed blade, because fixed blade, because of the aerodynamic shape, it is diverging section. So velocity will decrease and pressure will increase. It is easy to understand. But what about the moving blade? What is happening in moving blade? That velocity and pressure both is increasing. What is here happening? So I will make you understand that because we are seeing that moving blade is also diverging section. Moving blade is also diverging. So whatever velocity is going v1 to v2, so velocity should decrease, but velocity here is increasing. But don't think about the absolute velocity. Think about here the relative velocity, because it is moving blade. So whatever is happening, that will, I mean, if anything is moving, so the resultant behavior will be the relative content of that moving object. I mean, if you are traveling with the bus, and if you want to compare your speed with a moving car, then of course, you will get to know about the what is the relative speed your bus to that of the car, so that you can compare. Okay. So what is the effect on that bus will be? Let's say someone thrown a ball from the car to bus. So the speed of the ball will depend on the relative velocity of bus and car. I mean, whatever the effect will be, that effect will basically depend upon the relative velocity. That's why we will see the relative velocity. Whatever the effect will be in this section, that will be because of the relative states of the relative properties of the things. So that's why this moving blade is diverging. So if we want to compare the properties, let's say velocity, so we'll see the velocity. So here relative velocity will decrease because it is moving. Relative velocity will decrease, and because relative velocity is decreasing, pressure will increase. Now here relative pressure or absolute pressure is same. Okay, we are not talking about here the gauge pressure. We are just talking about the pressure. So the effective content of the velocity is because decreasing. So because of that, the pressure is increasing. Now the question is that, okay, understood that relative velocity is decreasing, but what about the absolute velocity? Why the absolute velocity is increasing? So we'll understand it by velocity diagram. From the velocity diagram, clear. It will be clear to understand it. Okay, fine. Now there are some points to remember that in axial flow compression, air flow in a direction parallel to the axis of rotation, and it consists of number of stages. Okay, each stage consists of a set of fixed and moving blade. Blade cross section passage is made diverging type of for fixed and moving blade.